Plenum cable is required for satellite installations. Plenum cable is designed for use in air handling spaces like plenums and ducts. It uses a fire-retardant material to help prevent the spread of fire. Plenum cable is not required for captive internal wiring. However, it is recommended to use plenum cable for captive wiring installed in air handling spaces. All low-voltage wiring must be installed according to the National Electrical Code, or NEC. The NEC standards ensure the safety of electrical installations. The NEC requires low-voltage wiring to be installed to minimize fire and electrical shock risks. Article 725.1 of the 2023 NEC covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. These circuits are characterized by voltage and current limitations, reducing electrical fire and shock hazards. Article 725.3 provides a summary of requirements, referencing other NEC articles based on circuit classification and application. Chapter 3 addresses wiring methods and materials. Article 300.21 focuses on spread of fire and products of combustion, stating installations through fire-resistant rated walls, floors, ceilings, or similar assemblies shall maintain the fire resistance rating. Openings around wiring must be sealed or closed using approved methods to prevent fire spread. Article 300.22 covers wiring in ducts, plenums, and other environmental air handling spaces. 300.22b addresses wiring in ducts used for dust, loose stock, or vapor removal. No wiring systems are permitted in these ducts. 300.22c covers other spaces used for environmental air, often referred to as plenums. Only wiring methods suitable for the purpose can be installed in these spaces. Cables and conductors must be Type MI, Type MC containing listed gas-tight continuous corrugated aluminum sheath, or other wiring type specifically listed as plenum rated. These cables are identified as Type CMP. Optical fiber cables must be Type OFP. 300.22d discusses information technology equipment rooms, defining specific requirements for wiring in these spaces. Article 725 provides additional rules for Class 2 and Class 3 circuits. 725.135 concerns wiring methods on supply side of the power source. 725.135 states wiring must comply with Chapter 3. Wiring suitable for mains voltage, such as 120 volts or 277 volts, is acceptable. 725.135b covers separation from other conductors. Class 2 or Class 3 circuit conductors must be separated from conductors of electric light, power, Class 1, non-power limited fire alarm circuits, and medium power network-powered broadband communications circuits. This separation prevents voltage induction and potential hazards. The separation requirement applies unless a barrier is installed or the Class 2 and Class 3 circuit conductors are enclosed in a raceway or cable. Article 725.136 covers wiring methods and materials on the load side of the Class 2 or Class 3 power source. 725.136 permits use of specific cable types including CL2, CL3, CL2P, CL3P, CL2R, CL3R, CL2X, and CL3X. These designations indicate suitability for general use, plenum, riser, and limited use applications. 725.136b allows substitutions based on fire ratings and cable characteristics. For example, a CL3P cable can be used in place of a CL3 cable. 725.136c addresses Class 2 and Class 3 cable uses and markings. Cables must be durably marked to indicate their type and intended use. Table 725.154 provides allowable ampacities for Class 2 and Class 3 cables. Ampacity depends on conductor size, cable type, and installation method. 725.143 covers circuit load considerations and overcurrent protection. These circuits must be protected against overcurrent based on the limitations of the power source in connected equipment. In summary, Plenum cable requirements are driven by 5 safety concerns in air handling spaces. The NEC provides detailed guidance on acceptable wiring methods, separation requirements, and cable types for low-voltage systems. Article 800 covers communications circuits. These circuits include telephone, data network, and cable television wiring. The article outlines requirements for wiring methods, grounding, and protection. 800.24 provides general wiring requirements. Communications wires and cables installed exposed on the surface of ceilings and sidewalls must be supported by the building structure in such a manner that the cable will not be damaged by normal building use. Attachment methods shall not cause damage to the cable. 800.25 covers cable routing during construction. Cables must be protected from physical damage. Where subject to physical damage, cables must be installed in raceways, enclosures, or otherwise protected. 800.50 addresses general protection requirements. Communication circuits must be protected from overvoltages and overcurrents. Protection devices must be listed for the purpose. Article 800.93 details grounding methods. Communications cables entering a building must be grounded to the building's grounding electrode system. This grounding minimizes voltage surges and provides a path for fault currents. 800.110 covers overhead communications wire and cable runs. Overhead spans must comply with minimum clearances above ground and other objects. Cables must be properly supported and secured to prevent sagging. 800.113 concerns underground communications wire and cable runs. Underground cables must be installed with sufficient burial depth to protect them from physical damage. 800.133 details the installation of communications wires and cables with respect to other building systems. Communications cables must be separated from power conductors to prevent induction and potential hazards. The separation requirement applies unless a barrier is installed or the cables are enclosed in a raceway. Article 800.154 provides cable marking requirements. Communications cables must be durably marked to indicate their type and intended use. The markings help identify the cable and ensure it is used in accordance with its listing. 800.179 concerns the listing and marking of communications equipment. Equipment connected to communications circuits must be listed for the purpose. The listing ensures the equipment meets safety standards. 800.182 covers the use of communications wires and cables in environmental airspaces. Cables installed in ducts, plenums, and other spaces used for environmental air must be listed as plenum rated. These cables, designated as Type CMP, have fire-resistant characteristics. 800.182 allows communications wires and cables installed in ducts and plenums specifically constructed for environmental air to be Type CMP. 800.182b covers the types of communications wires and cables permitted. These include communications wires and cables Type CMP and communications raceways listed for use within ducts and plenums. 800.182c describes the removal of abandoned cables. The accessible portions of abandoned communications cables must be removed. 800.182d describes the fire stop system. Where communications cables penetrate fire-resistant rated walls, partitions, floors, or ceilings, the fire stop system must be tested and listed for the penetration fire resistance rating. 800.182e covers openings for communications systems. Openings around communications cables must be sealed or closed using approved methods to maintain the fire resistance rating of the assembly. In summary, Article 800 of the NEC provides comprehensive requirements for communications circuits. These requirements address wiring methods, grounding, protection, cable markings, and cable use in environmental airspaces. The goal is to ensure the safety and reliability of communications systems. When dealing with low voltage wiring, and especially network cabling or satellite cabling, it's important to understand the different cable types and their applications. For network cabling, you have categories like Cat5e, Cat6, Cat6e, and so on. These categories define the performance characteristics of the cable, such as bandwidth and data transmission speed. When running network cables in a building, you need to consider the environment where the cables will be installed. If the cables are running through a plenum space, which is an area used for air circulation, like above a drop ceiling, you must use plenum-rated cables. Plenum cables are designed to be fire-resistant and produce minimal smoke if they burn, which is crucial for preventing the spread of toxic fumes through the ventilation system. For satellite installations, coaxial cables are typically used to transmit the signal from the satellite dish to the receiver. Like network cables, coaxial cables also have different types and grades. When installing satellite cables, you also need to consider the environment. If the cables are running through a plenum space, you should use plenum-rated coaxial cables. Additionally, grounding is essential for both network and satellite installations to protect against electrical surges and ensure proper signal transmission. Proper cable management is also crucial for maintaining a clean and organized installation. Use cable ties, straps, or raceways to keep the cables neatly bundled and supported. This not only improves the appearance of the installation, but also prevents damage to the cables. When working with low voltage wiring, always follow the manufacturer's instructions and local electrical codes to ensure safe and compliant installation. If you're not comfortable working with electrical wiring, it's best to hire a qualified electrician or low voltage technician to handle the installation. They have the knowledge and experience to do the job safely and correctly. Remember, safety is always the top priority when working with electrical systems.